All right, Year 11, I'm going to move on now to the next exercise, which is angles of magnitude. So solving these trig equations here. And it's really quite easy once you have a go at these. You'll find them quite easy. As long as you remember some basic things from before. So your standard go-to all stations to central. Here you find the acute angle. Remember that's 90. That's 180. 270. 0 our start point, or 360. But remember, we've also got to think in radians. So pi on 2, pi, 3 pi on 2, 2 pi. And also we need to know that in this one, it's 180 minus the angle, and here it's 180 plus the acute angle, and here it's 360 minus the acute angle, or pi plus the angle if it's in radians, minus. Pi plus the angle and 2 pi minus the angle. Sometimes it's better just to remember the curve. All right, so I'm going to start with 1b. I don't know why Margaret starts off with a decimal. I wish she hadn't, but anyway. So cos theta equals -1/2. Now we know you can just go inverse cos, and that'll give it to us. And if you do that on your calculator, it gives you 60 degrees. Sorry, that was the wrong one. I'm going to put the negative in. It gives you 120 degrees. It gives you the first angle. Be careful though, that won't always be the case. But we know that it goes on and on. We know that the cos curve there it is. We've got -1/2. So we get one answer there, which we've worked out is 120, and we get one answer there. Now the problem with doing it on your calculator and getting that 120 is you don't remember what the acute angle is, which is vital for this. So you go, okay, 1/2. I'm going to draw up this one, which is my 60/30. Now the one that gives me 1/2, the cos ratio that gives me 1/2 is adjacent over hypotenuse. So that's 60. So the acute angle is 60 degrees. But this is -1/2. So I need it here and here. Oh, sorry. Get rid of that. Here and here. That's where cos is negative. So it's going to be 180 minus 60, which we already know because that's what the calculator gave us, which is the 120. But it's also 180 plus 60, which is 240. And then you can check that on your calculator and see which answer, make sure you're right. So it's pretty easy. Well, let's do D. Sine theta equals √3 on 2. Now we need to find the acute angle, and we're lucky because the acute angle would be what our calculator will give us. There's sine. We know √3 on 2 is a little bit less than 1, so we're going to get one angle there, and we're going to get one angle there. Now what are they? Well, this is the acute angle, and this is 180 minus the acute angle. So if I find that acute angle, which I can by just using my calculator, but it's better if I just go down here to this little triangle, root 3 on 2, it's 60. Oh, wasn't that lucky? So we get 60 and we get 180 minus 60, which gives us 60 and 240. That's a terrible zero. Oh, what am I doing? 240, 60 and 120. And again, you check it on your calculator. And that's all you have to do. Find the acute angle and decide what quadrants you need. Now, I'm going to go back now. I'm going to do A because you have to use your calculator for this. And it's sine theta equals 0.35. Sine theta equals 0.35. So again, it's going to be in this same thing. Here's sine, and I know that 0.35 is down here. So I'm going to get an angle there, and I'm going to get an angle here. And that's at 180 minus. So if I find the acute angle, now to do that, I actually have to have my calculator in, it's in degrees, so I'm going to be doing degrees, and I inverse sine it, and that's going to give me an acute angle. And I use that, so I go shift sine 0.35, and I put it in degrees, minutes, and seconds. I get 20 degrees, 29 minutes. But the other one is 180 minus 20 degrees and 29 minutes. So my two answers are 20 degrees and 29 minutes. And 180 minus that, which is 159 degrees, 31 minutes. Now, as soon as all you have to do is use the acute angle, find it, and then decide, well, which quadrant is it in? Which quadrant is it in, and what am I going to use? Now, if they give you one like, let's go here. Yeah, we'll do this one here. We'll do these two. Sine squared x equals 1. So, what question was that? K. K, which is sine squared x equals 1, which means, I square root both sides. So sine x equals plus or minus 1. Well, I can actually just use a graph for that. Now remember, you get two answers when and we're going 0 to 360. That's why there's only two answers. We could have an infinite amount of answers if it went on forever, which it does. Now, sine x equals plus or minus 1, well, that's that one there and that one there. So the two answers are x equals 90 degrees and x equals 270. Let's have a look at the next one. This is what we call an equation reducible to a quadratic. So you've got to be careful because some people go, I'll just divide by cos x, which gets rid of it. So it's an equation reducible to a quadratic, or we can factorize. So this is L, we've got 2 cos squared x minus cos x. So L 2 cos squared x minus cos x equals 0. Well, we'll factorize out the cos x. And here I get 2 cos x minus 1 equals 0. I just factorized out the cos x. Well, now I've got two solutions. I can have cos x equals 0, or I can have 2 cos x equals 0, minus 1 equals 0. Let's just deal with this cos x equals 0. So I draw a little graph over here, and there are two answers, that one and that one. So x equals, well, what are they? 90 degrees and 270. But over here, I get, cos x can equal a half. And again, I get two answers. I'll go back to my triangle. Cos x equals a half is 60. But they're positive. So I'm going to get x equals 60. Now, where else is it positive? In the last quadrant. So 360 minus 60. So 60 or 300. So there are 4 solutions to L. And they're 60, 90, 270, and 300. Well, what about if they decide to write it in radians? If they decide to write it in radians. So look at question 3. And again, question 5. So we're going 0 to 2 pi for these. So let's try one of those. Let's try 3D. Cos x minus 1 equals 0. So that means cos x equals 1. Again, I like to draw the curve. And I get two solutions from 0 to 2 pi. And they are 0 and 2 pi. So x equals 0 and 2 pi. Now, those ones are really easy in question 3, because they're all when it's 0 or 1 or negative 1. I want to get to question 5. So let's have a look at 5. And we get 5a, cos x equals a half. So cos x equals a half. Well, we know there are going to be two answers between 0 and 2 pi. And they're going to be there and there. So we need to find the acute angle. Well, I'll just draw this. But this time, instead of degrees, I'm going to put pi on 3, pi on 6, and I get 1, 2, root 3. So my acute angle, when I find that, is going to be pi on 3. And that's the first one. Where else is it positive? In the last quadrant, which is 2 pi minus pi on 3. Now, as you do more of these, you'll get better at that, but you've got to create a common denominator here. And to create a common denominator, you need to put that on 3, so you need to multiply that by 3. So you've got 6 pi on 3, because that's what 2 pi is, minus 1 pi on 3, which gives you, so I've still got my pi on 3 there, my first one, 5 pi's on 3. If you eliminate the pi somehow, you got it wrong. If you somehow do that and eliminate the pi, you've got it wrong. Let's have a go at another one, and then you can have a crack yourself. So let's do sine x equals negative 1 on root 2, b. Sine x equals negative 1 on root 2. Now, again, you can draw the curve, and you can see that you're going to get two answers, one here and one here. But you've got to find the acute angle. And the acute angle for 1, 1, root 2 is pi on 4. So, well, where is sine negative? Sine is negative at pi minus the acute angle. Plus the acute angle. Look up here. Pi plus the acute angle, this one here. And this one here, that's where sine's negative. So pi plus the acute angle and 2 pi minus the acute angle. That's where sine's negative. And what's the acute angle? Well, the acute angle is pi on 4. So it's pi plus pi on 4 and 2 pi minus pi on 4. Now again, you've got to have common denominators. So this is 4 pi on 4. That's easy. So I get 5 pi on 4. But this one, I'm going to have to multiply that by 4 to get it on 4. So it's going to be 8 pi on 4 minus 1 pi on 4. So 5 pi on 4 is one of them. And the other one is 7 pi on 4. All right? And that's, what question is that? That's B. So, what you need to do to solve these, find the acute angle, decide what quadrant it is in, and then do the appropriate calculation. Now, if you're in degrees, if it's the acute angle, well, it's just that one in here. If it's in this quadrant, it's 180 minus. This quadrant, 180 plus. This quadrant, 360 minus. But if you're in radians, it's pi minus, pi plus, or 2 pi minus. And you just have to apply those rules. Find the acute angle. So you should write that down. 1, find the acute angle. 2, find what quadrants. I can't even spell quadrants. And then apply the correct algorithm. So 180 minus, 180 plus, 360 minus, or pi minus, pi plus, 2 pi minus. So that's all you got to do. Good luck with that.